So here's the sine of 15 that we need to find. Unfortunately, that's not one of our unit circle angles. However, if we look at the difference, whoa, how'd that get there? 45 minus 30, that's clearly the same thing as 15. So that would be sine of a minus b. Sine of a minus b is sine a cosine b minus sine b cosine a. So this would be the sine of 45 cosine of 30 minus the sine of 30 cosine of 45. Sine of 45 is radical 2 over 2. Cosine of 30 is radical 3 over 2 minus the sine of 30, which is a half, radical 2 over 2. Nice thing, I have a common denominator, so it's just the square root of 6 minus the square root of 2 all over 4. So here I noticed that I have 5/12. So 5 over 12 is the same as 1/12 plus 4/12. I don't know anything about 1/12 angles. 5 over 12 is also 2/12 plus 3/12, which is equal to a sixth plus a fourth. So if I put pi's on there, I'm all set. So we'll do the cosine of pi over 6 plus the cosine of pi over 4, where the cosine of a plus b is cosine a cosine b minus sine a sine b. So cosine of pi over 6 times the cosine of pi over 4 minus the sine of pi over 6 sine of pi over 4. Sorry about that. Cosine of pi over 6 is radical 3 over 2 times radical 2 over 2 minus 1/2 times radical 2 over 2. That's a 2. So I get the square root of 6 minus radical 2 all over 4. That's a sad looking 2. Okay, tan of a plus b, I'm pretty sure that's what we're going to need because that's a pretty big angle, is tan plus tan b all over 1 minus tan b. 17 over 12 is equal to 1/12 plus 16/12. I don't have a 1/12 angle in my bag of tricks, so 17/12 is 2/12 plus 15/12, which is a sixth, plus if I divide both of these by 3, I get 5 over 4. I squeeze some pi's on there. I'm all set. So I have the tan of pi over 6 plus 5 pi over 4 is equal to the tan of pi over 6 plus the tan of 5 pi over 4 all over 1 minus the tan of pi over 6 tan 5 pi over 4. Pi over 6 of tangent is 1 over radical 3 plus tan of pi over 5 pi over 4. Pi over 4 with tan is 1. 5 pi over 4 is in the third quadrant, so that's plus 1 all over 1 minus the same values. Oops. Times 1. So I now have 1 over radical 3 plus 1. 1 minus 1 over radical 3. Complex fractions are bad, so let's multiply by the common denominator times the numerator and the denominator. So if I multiply those two, I get 1. These I get plus radical 3, and I get radical 3 minus 1. I'm okay with having radicals in the denominator, so that's the end of that one.